In the last video, we have created a value manager that maps grid of values into a grid of integers and provide functionality towards accessing this grid. In this video, we will create a pattern manager class with all its additional classes. This is an important part of our algorithm, as the algorithm relies on the data that you provided and creates output based on this data. This means the better strategies you apply here, the better the output image will look like. Let's go to the editor. We need to create a new folder called patterns. Okay, rename. And here we want to create a pattern manager class. Let's open it. Let's put it in our namespace and delete the monobehavior inheritance. Okay. We will need two dictionary fields, one that takes int as a key and returns pattern data, and second that takes int key and returns pattern neighbors. Let's create them and I will explain what they does. The class name is called pattern data, and we will call it pattern data index dictionary. And second dictionary will take pattern neighbors as the value. And we will call it pattern possible neighbors dictionary. Okay, so we will have two dictionaries that maps pattern to an integer index. First dictionary will store pattern data, the information about patterns. The second contains data about neighbors for the given pattern. The second dictionary could be merged into our pattern data class, and we could store the neighbors inside the pattern data class. I have left it as a separate collection, but as I have said before, the more time you spend refactoring, the cleaner your code will get. Let's implement the remaining fields and then we will create placeholders for our classes and implement the classes one by one. So another thing we need is int pattern size, and we will set it equal to -1. And we will need something called iFindNeighbor strategy. And we will call it strategy. We will store pattern size in this class as it will be passed by the user. Last field is called iFindNeighbor strategy. This is an abstraction of a strategy for finding neighbors. We have discussed about two implementations, searching a grid and comparing pattern values, the values that can overlap. In each case, the pattern size is greater than 1. For the first strategy, we will use pattern of size 1, and for patterns of size greater than 1, we will use the second strategy. Because we are using abstraction, so iFindNeighbor strategy interface, you could possibly implement your own strategies here, depending on what you need. The more abstraction and generic code we have, the more tweakable it is and the more reusable it is. So now let's create placeholder classes for all of those names, and we will start implementing that pattern data class. So be sure to copy the names and let's create let's go back to the editor and let's create our helper classes. Pattern data. Open back the code editor. Pattern neighbors. For iFindNeighbor strategy, we will create a separate folder. Let's create a folder called strategies. And let's create a new class here. iFindNeighbor strategy, and we should be good to go. So let's now open pattern data and we will create this class. So let's place it in our namespace and delete the monobehavior inheritance. Pattern data class will store pattern and frequency, so how often pattern is present in our input image. So let's go and start implementing it. we will need a private pattern field. Since the class is quite short, we will implement pattern class at the end. Let's create an integer value for frequency. We will also need a frequency relative and frequency relative log2. And those will be floats. Let's create properties to access frequency relative. We will also need to access pattern. And we will need to access log2, frequency relative log2. Okay, great, and we'll need only getters for those properties. So now let's create a constructor. It will take pattern as input. We also want a helper method that adds to frequency. We will also need a helper method that will add to frequency called add to frequency. And it will call frequency ++. Okay, and we also need calculate relative frequency method. It will be void method. It will take int total. And this will take the relative frequency and calculate it by dividing the frequency by the total. And we will need to call cast one of those to float so we can calculate the float value. And we also will calculate the log2 of the frequency by calling mathf.log and pass it frequency and 2 as the base. First value is the value to be calculated, and second is the base for the logarithm. Okay, and the last method will be compare grid. It will return bool value and it will take direction and pattern data. And we will return pattern, compare pattern to another pattern, and pass the direction and pattern data dot pattern. Okay, it might look complicated right now while we don't have the helper method, the helper classes, but that's the easiest way to implement this code to be clear and readable. And we will start from implementing the direction class. It will be an enum, and it's pretty short. So let's go to the editor and create dictionary class, direction class. Okay, we can create it in helpers. So let's create new C# script direction, and let's open it. Let's place it in the namespace and let's change it to enum. Okay, and here we need to have up, down, left, and right. As stated previously, we will check the patterns in the cardinal directions. And we also have here another class that is static. It will be called direction helper. This will only have one method. It will be called get opposite direction to. It will take direction and return a direction. And also it will be an extension method, so we can directly call it on an instance of direction. So let's create public static direction get opposite direction to. And we will pass it this direction. Okay, and we will here use a switch statement to return an opposite direction to the direction that was passed to this method. If you haven't yet used extension methods, we will be able to call direction.getOppositeDirection to on any direction, and it will return a opposite direction. Okay, so let's implement the switch statement. And call feature is that if we create it and pass it direction and enter and go down, it will automatically create our switch statement. And we just use return direction and return opposite direction. And in any case, we will just return what we have been given. But it should never happen. Okay, so that's the whole direction class. Let's get back to pattern data. So direction class is an enum that will represent directions when it comes to neighbors list. We will use it for finding neighbors in the given direction. The direction helper will be used when we are comparing patterns and we want to get the other patterns opposite neighbors to compare them with the neighbors that we have from our end. Okay, so now we have only to create the pattern class. So let's go to the editor and create it. We create it in pattern folder. Let's create a class called pattern. Double click it. We'll pass let's put it in our namespace and let's delete the monobehavior inheritance. Pattern class will store a grid of integers that contain the value indices that the pattern represents. If we have pattern of size 1, it will be a single value stored in a jagged array of 1. For further generalization, we could extract an interface from this class so you can more easily create your own version and apply it to wave function collapse algorithm. Let's create some fields. We will need int index, jagged array of ints called grid, and for now that's it. Okay, we will also need a property string called hash index. Okay, and we will need an accessor for index. So let's create property with only get. Okay, now let's go to the constructor. The constructor will take a jagged array of integers for grid, a string for hash code, and int value for index. And let's assign those values. Okay, great. Now let's implement the remaining helper methods. We will start with set grid value and get grid value. Set grid value will take coordinates and value as integer and set it to grid. Please remember that y is passed as first because it represents the rows and x second as it represents columns. Now let's create get grid value that returns int, the value from the grid. Next method will check value at position, so it will be comparing values. It will return bool value and take x, y, and index and int value. So we will return if value is equal to what we have inside our grid. Next method is a bit more complicated. It is compare pattern to another pattern. So you might remember we have discussed this strategy where we are comparing patterns to see if they can be neighbors. So this method will be used in that process. So it will return bool value and take direction and pattern. So let's implement this as internal method. and in it will create two jagged arrays, my grid and other grid. Now my grid will be the grid. My grid will be created using a get grid values in direction method that takes direction as input. Let's create a placeholder for this method, and other grid will be called on pattern that we have been passed in through the parameters, and call the same get grid value in direction method, but in the opposite direction using the get opposite direction to method that we have implemented in our direction class. And this is how we are using the extension methods. We have our direction passed in, and we can call it on it get opposite direction to, and it will automatically return the correct opposite direction. Now we will loop through my grid and compare values against the other grid. We will call if my grid row call is different than other grid row call, and in that case return false. And if everything matches, we'll return true. Okay, now we have to implement get grid values in direction. So get grid values in direction is a tricky method. It is responsible for accessing the correct part of our value grid depending on which direction do we want to compare it in. We are creating a new jagged array that is of correct size and use it for selecting the correct part of our value grid. Since jagged array, like all arrays, are passed by reference, we then can return the same array after processing it. So let's get to it. We will use a switch statement as before in our extension method for a direction class. So first we will initialize a new jagged array of ints. We'll call it grid part to compare. Okay, and it will be only a placeholder. Now let's use a switch statement and pass it there. Okay, now we have the preset. So first of all, we need to create the appropriate size, instantiate the jagged array of appropriate size. So we will call my collection extensions, our helper method, and we need to use helpers. Create jagged array, and the size will be in the up direction grid dot length -1 and grid dot length. Remember that our patterns are always squares, so that's why we are using only one length. And because we always leave one row unchecked and take all the other rows for comparison, that's why we remove one in the appropriate place, depending on which direction we are working towards. Remember that up and down direction will have the same grid size, but the spaces will be taken differently. For up direction, we'll take the second row and up. In the down direction, we'll take one before last until the 0th row. So let's create the arrays for each direction. Okay, now we can create an additional method called create part of grid. Okay, and it will take x minimum, x maximum, y minimum, y maximum, and our grid to fill in. So for each example, we'll take different values here. So x minimum is 0, grid.length is maximum, as we take all the columns but limited number of rows. In the up direction we are ignoring row 0, so take first row up until the last row. And we pass our grid part to compare. Let's copy this method to other methods, to other switch cases. And we need to change the values. Here we will delete the 0 here and take -1 as the y max. Here we will take 0 here and reduce -1 on axis, on max axis, and switch y min to 0. And in the right we will take first column up until the last one and all the rows. Okay, and now we need to create break statements. In the default case we will return the grid. Okay, and at the end we will return the grid part. So as I said before, this is quite tricky, but all it does is to take the appropriate value for x and y minimum and maximum, to take appropriate values from our grid into jagged array and return it for the comparison. So let's instantiate this method. Okay, great. Let's rename the values as x min, x max, y min, y max, and grid part to compare is good. Now inside this method we will need to create a list of integers called temp list. Now we will loop through the x min, x max, y min, y max and add all the values from our grid into our list. So let's do it. First for row, and row is y max, and we start from y min. For column we will start from x min and end on x max. Okay, and we call list.add grid and access row and col. Okay, great. So now we have taken all the values that we need to compare inside our temp list, and now we'll need to loop through this list through list.count, and we will recreate the x and y coordinates based on the index, knowing the grid part to compare length. So let's create x, and it is index %, so a remainder of grid part to compare dot length, and y coordinate is index divided by this length. Right. And we call grid part to compare, and it will be equal to the list position. Okay, so to summarize, this method takes the data constraints required to extract collect values from our value grid stored inside the pattern and fill the jagged array passed into as a parameter with the correct indices. Okay, so now that we are done with patterns, let's move back to the pattern manager. So we can see that all we need to do is implement the pattern neighbor class and I find neighbor strategy, That we will do in the next video.